In 4a, we are told that the sine of the angle theta is 0.2. Then we are asked to calculate cos theta. This is different from the other questions where we were just asked to calculate theta, the angle. But we are still going to do that. We're going to first calculate the angle, just like we did in the other questions. And then we know the angle, we can evaluate cos of that angle to find the ratio. The one piece of information that is important before we do that is that the angle is obtuse. So first we're going to draw the unit circle. So we are told sine theta is 0.2. Sine theta, we're looking at the y value of 0.2. Between 0 and 180 degrees, that happens twice. So 0.2 up the y-axis is about here. So we're going to have a solution on that part of the unit circle, and then one over here on this part of the unit circle, because both of those y values are 0.2. So then use your calculator to find the angle. So that's theta r for reference angle, and you get it's 11.5 degrees. So that is this angle inside the little right angle triangle. That's 11.5 degrees. We then need to find the other solution. So what we're going to do is write 11.5 degrees in the other right angle triangle, and then we need to find the obtuse angle. So to do that, we take 180, subtract 11.5, and then you get 168.5. So that means sine of 11.5 will give you the ratio of 0.2, and sine of 168.5 will also give you the ratio of 0.2. So now it's important to go back to the question. It says that the angle theta is obtuse. So there's only the one angle that we're interested here. We're not interested in the acute angle. We had to find that acute angle because that's what our calculator finds, and then we use that acute angle to find the obtuse angle. But now we don't want both solutions, we only want the obtuse solution. So now we're going to take this angle and we are then going to find cos of 168.5 degrees, and you just enter that right into the calculator. This question's a little bit tricky to round. We want to 3 decimal places, so we're going to cut it off over here. So this 9 is going to bump that up. So this rounds to negative 0.980 to 3 decimal places. And there is no surprise that this ratio is negative because the x value in this right angle triangle on the left side of the y-axis is negative. So we know that the cos ratio of an obtuse angle is negative. And just note that if you were to take cos of 11.5, which you don't need to do, but if you were to do that, you would get the positive 0.980. It's the same distance away. These x values are the same distance, just in opposite directions. So 4b says that cos theta equals negative 0.6. So cos is x. So we are going along the x-axis, negative 0.6. And then we have that right angle triangle. There is only one possible angle between 0 and 180 degrees that will give us this ratio when we take cosine of that angle. So that fits. We are told that the angle has to be obtuse, and that works out with the math. So then you just use your calculator to find the angle is the inverse of negative 0.6, and you get the angle of 126.9 degrees. So that's this angle here from the positive x-axis, and then you find the sine of that angle. And you get 0.79986. So then round after 3 decimal places, that rounds to, well, this 8 bumps this 9 up to a 10, which will then bump this 9 up. So it's actually 0.800. And you should not be surprised that the sine ratio is positive because we know acute and obtuse angles, if you take the sine of those angles, are both positive.